Indices with negative bases. Minus 2 to the power of 3 minus 2 to the power of 3. What's the difference between them? In this example, the base is minus 2. In this example, the base is positive 2. That minus is separate, so we're actually looking at this. That power of 3 only goes on the 2, and then once you've worked out what this part is, you put the minus in front. If you look at the rules of BIDMAS, for this one here, there's no brackets. There are indices, which is why you do this part first. Division, no. Multiplication, no. Addition, no. Subtraction, there's a minus there. So you do the 2 to the power of 3 first, which will give you 8, and then you put the minus on afterwards. I know you get the same answer on this side, because minus 2 times minus 2 times minus 2, or minus 2 to the power of 3, will also give you minus 8. But what I'm focusing on here is which one has a negative base. Only this has a negative base, because the negative number there is in brackets, and this one has a positive base. Negative bases and integer, meaning whole numbers, integer indices. Minus 2 to the power of 3, so we write minus 2 3 times, all multiplied together, and that gives minus 8. Minus 2, negative base, to the power of 4, which is an integer. A minus times a minus is a positive number, times a minus gives you a negative, times a minus gives you a positive number. So this will give plus 16. This shows that if you have a negative base and an odd power, a whole number, but odd, then you can write it like this. Without the brackets. And if you have a negative base and an even integer power here, then you can write this as this. So that minus there is doing nothing because that's an even number. So we can generalize this into a little rule here. A negative base, and m is the power, an integer power. So m could be odd or even, and depending on what it is, we'll get one of these. So if m is odd, we can write this without the brackets, and if m is even, we can write it without the brackets and the minus. So a further example, a negative base, and the power there, the index, is odd. And looking at this, it's saying just take the brackets out, so I can write it like this. Of course, that can be simplified further. This side here, a negative base, but this time we've got a power that's even, and as I said before, I can take the minus and the brackets out, so that will be just 3 to the power of 4. So this one's minus 27, and this one's 81. So we've looked at negative bases with integer indices. Now we're going to look at fractional indices. The power of a half means the same as square root. And we're square rooting minus 2, and you know that you can't square root a negative number, So this doesn't have much meaning here. Minus 2 to the power of a quarter, I could rewrite this as minus 2, and the quarter, as you know, is the same as a half times a half. So I could have all of that to the power of a half, and then raise that to the power of a half again. As you can see, the power on power rule here, a half times a half is a quarter, so this is the same as this. And inside here you can see the minus 2 to the power of a half, which is this again. Again, this has no meaning. Minus 2 to the power of minus a half, so I might want to write this as 1 over minus 2 to the power of, and remember the rule where you change the sign, so if that's minus, this has to be a plus. And again you can see that minus 2 to the power of a half, which is what you had there, which was the square root of minus 2, meaningless. So this also carries no meaning here. Minus 2, we're square rooting it. You may have spotted a pattern here, that in these fractional indices, the denominator in all of these is an even number. The denominator is even. So then you have no meaning when you have a negative base. The numerator doesn't matter. It doesn't matter what the numerator is. So, for example, if I change that 1 there to 3, for instance, so all I'm going to do on this side is like cube everything. I've still got the square root of a negative number. This still has no meaning. In these 3 examples, we have fractional indices and we have a negative base. The denominator this time is odd. So all of these do have a meaning. To the power of a third, minus 8 to the power of a third, which is the same as a cube root. 1/3 as a power means a cube root. The cube root of minus 8 is minus 2. The cube root of minus 125 is minus 5. So this one also works. This has a base of minus 32 raised to the power of 1/5. So that will give you minus 2. So all of these work when you have an odd number in the denominator. So we can summarize the effects of indices on a negative base like this. So this is the first part of the video, where m is an integer, and for odd values we said the brackets can be removed. For even values we said the minus and the brackets can be removed. And when we have fractional indices with a negative base, if the denominator is odd, then there is a meaning to this, and we can remove the brackets and write it like this. And if the denominator here is even, there's no meaning. You should memorize all of these results.